Hi everyone, I am Dr. Sadish Kumar, Professor, Department of Physics, K.S.Rangasamy College of Technology, Tiruchengodu. Today in our topic is ultrasound. The topics covered introduction, characteristics of ultrasound, production of ultrasound, application of ultrasound. Ultrasound. Ultrasound is a sound with a frequency greater than 20 kHz. The frequency is non-audible for human. Naturally, the ultrasound produced by bat, whales, and dolphin. The echolocation is a method used by dolphin and bats to locate and catch food such as fish and insects. The characteristics of ultrasound. The ultrasound operates at the above frequency range of 20 kHz. Ultrasound is a high frequency sound waves. Ultrasound is a high energy waveform and ultrasound obey all the sound laws. The production of ultrasound by the method of inverse piezoelectric effect. The principle of inverse piezoelectric effect is when an electrical energy is applied to the crystal, it will produce ultrasound. That means in the form of vibration. And simply, electrical energy converted into mechanical energy. The production of ultrasound by the method of inverse piezoelectric method. The construction of circuit. The NPN transistor, the emitter circuit is earthed. The base circuit is connected to the variable capacitor C1 and coil L1. The collector circuit is connected to the coil L2. The power supply is connected as shown in figure. The coil L1 and L2 is act as the primary coil. In secondary circuit is connected to the coil L3 and two conducting plate is separated by the quartz crystal. The working of inverse piezoelectric method. When the battery is switched on and hence the current is produced by the transistor in the circuit. The collector and base current is passed through the coil L1 and L2 of the primary circuit. This current induced EMF produced in the coil L3. Induced current applied to the conducting plates A and B. Due to the principle of inverse piezoelectric effect, the crystals start vibrating. The frequency of oscillating circuit is adjusted by the capacitor C, and when this frequency is equal to natural frequency, resonance occurs. At resonance, the crystal vibrates vigorously and ultrasonic waves are produced at the other opposite face of the crystal. The condition for resonance, the frequency of oscillatory circuit equal to natural frequency of the crystal, or 1 by 2 pi root of L1 C1 equal to P by 2L root of E by rho. L is the length of the crystal, E is the Young's modulus of the crystal, rho is the density of the material, P is equal to fundamental first overtone, second overtone respectively. The production of ultrasound. Another method is magnetostriction method. The principle of magnetostriction method is when an alternating magnetic field is applied through the ferromagnetic material like ferrous, cobalt, nickel will produce ultrasound. In other words, electrical energy converted into mechanical energy. The production of ultrasound. In another method, magnetostriction method. The construction of the circuit. The NPN transistor emitter circuit is earthed. Base circuit is connected to the coil L2 and negative of the battery, and collector circuit is connected to the milliammeter, coil L1 and variable capacitor C1 and positive of the battery. The coil L1 and L2 is wound in ferromagnetic material like a ferrous, cobalt and nickel. The ferromagnetic material is fixed with clamp. The DC source is applied to the rod as shown in figure. The working of magnetostriction method. Initially, the rod is permanently magnetized by passing direct current. The battery is switched on and hence the current is produced by the transistor. The collector circuit is passed through the coil L2. The EMF will be induced in the coil. Due to this effect, an EMF is induced in coil L1. The induced EMF is fed to the base of the transistor when act as a feedback continuously. In this way, the current in the transistor is built up and vibration of the rod is maintained. The frequency of the oscillatory circuit is adjusted by the condenser C, and when this frequency is equal to frequency of the vibrating rod, resonance occurs. At resonance, the rod vibrates longitudinally with larger amplitude, producing ultrasonic waves of high frequency along both ends of the rod. The condition for resonance, the frequency of oscillatory circuit equal to frequency of the vibrating rod. 1 by 2 pi root of L1 C1 equal to 1 by 2L root of E by rho. L is the length of the rod, E is the Young's modulus of the rod, rho is the density of the material. One of the major applications of ultrasound is sonar. The sound navigation and ranging is a technique that uses sound waves to detect and locate objects underwater, measure distance and communicate. The principle of sonar is sound echolocation. This diagram is explain the working of sonar. The working of sonar. The sonar operates on the principle of sound echolocation. It involves emitting sound waves into the water, which then travel until they encounter an object. The key steps in the sonar process are emission. A sonar device emits sound waves into the water. The reflection, when these sound waves hit on the object, they bounce back towards the sonar device as echoes. Detection. The sonar device has a receiver that detects these returning echoes. By measuring the time it travels for the sound waves to return, the device can calculate the distance to the object based on the speed of sound in water. The distance equal to speed of sound in water into time divided by 2. This formula is used for to calculate the distance to the object. Thank you.